Hello everybody. My name is Andrew Scoppa with DevelopMentor, and welcome to the Entity Framework Jumpstart. I have my email address here, ascoppa@develop.com. Please be sure to jot it down. If you have any questions after the presentation, please feel free to send me an email and I will respond. So we're going to get started with the topic. The first thing that we're going to be discussing here is the materials that are available to you that correspond to the presentation. I've created a OneDrive link that you can copy and use to access the materials at any time. I'll place this in the chat window, this link, so that you can feel free to walk along with the demonstrations as we're going through the presentation. I do want to note that the address is case sensitive. When you navigate to that address, there is a set of files. Let me go ahead and bring this down. 1 second. There we go. So we have the Entity Framework Jumpstart PDF, along with a folder containing a set of samples. As part of the presentation, we will be looking at a couple of these samples, and we'll do one demo interactively as well. The file instnwind is a zip file that contains a script, a SQL script, that you can use to set up the Northwind database that I'll be using as part of the demonstrations. So the objectives of this presentation, we're going to start by describing the entity data model. We'll learn about mappings, a quick overview of the entity framework architecture. We'll be looking at the DbContext class, along with Linq to entities. We'll discuss entity states and how to save changes. And we'll also look at entity framework async support. This is all pertains to Entity Framework 6. The presentation itself is at an introductory level. So if you have no experience with Entity Framework, this will be a perfect entry point. If you have been working with Entity Framework in the past, this can be used as a review. So let's start by answering the formal question. What is Entity Framework? So Entity Framework is an object-relational mapper, something that we'll be talking about going forward in more detail. The primary purpose of the entity relationships that are provided to us through Entity Framework is to enable .NET developers to work with relational data using domain-specific objects, in other words, classes, just as you would in your day-to-day programming with an object-oriented class system. And it eliminates the need for most of the data access code that developers usually need to write. For example, having to navigate through the relationships that are associated with most mapping systems that use relational databases without a mapping tool. Where can we find more information about Entity Framework? There's a wonderful link here that I provided directly from Microsoft through CodePlex. And if we want to take a quick peek at that link, I'll paste this out into our chat window so that you can all see it and navigate to this site. There we go. So here you'll have access to the Entity Framework content along with documentation and a support line. It's also available for people that are more experienced with Entity Framework, where you can actually contribute. So a little bit about the history of Entity Framework before we go into the details. It was introduced years ago as part of .NET version 3.5 Service Pack 1 and was available through Visual Studio 2008. And this provided a rudimentary object-relational mapping tool set for working with Entity Framework using what was known as a database-first workflow, which means that you start with a database, and from there you use a designer window to set up the relationships for your conceptual entities and program directly against the database through the conceptual model. However, that was very limited in its capability. Many developers wanted to do more. For example, starting with just classes. How do you go about extending it to work with Entity Framework? So in Entity Framework 4, they added support for that approach using what's known as POCOs, which stands for plain old CLR objects, along with some more sophisticated and performance-related improvements for what's known as lazy loading, customized code generation, and also something known as model-first workflow, where you can start with Entity Framework Designer and build your database infrastructure visually, and then using SQL DDL, build the database directly through the schema that's generated. Entity Framework 4.1 in April 2011 provide a simplified model using what we'll be using in this presentation called the DbContext API. They also added the support in here for what's known as code first, where you have no designer support, you're working directly with classes. Entity Framework 5 extended support by adding new features for what are called table-valued functions, and also spatial types and enums. And this version, version 6, Entity Framework is now open source. It's supported under a license through Apache, and the source code itself is hosted at Codeplex using Git. So let me go to the next slide here. Okay, so there are three options for developing with Entity Framework. The first one is model first, and here with model first you have, as I mentioned earlier, the ability to create a new model using Entity Framework Designer, which we will be reviewing, and then generate a database schema from that model. Database first, and this is the approach that we will be using in the presentation, allows you to reverse engineer an existing database. And the last approach being code first, that allows you to define your model using either C# or VB.NET classes. Okay, so what's the motivation behind Entity Framework? Well, most database schemas are optimized for data storage and consistency. So that means you have a normalization structure that's set up for the relationships between the tables that are described by foreign keys and table intersection. So that's where from the standpoint of performance, it is going to be at the database level much quicker than having non-normalized or flat tables. However, from the standpoint of a developer, it makes it difficult because the developer is now responsible for navigating or traversing the relationships by associating the foreign keys with the primary keys that are mapped in the schema. So as it says here, there's lots of plumbing code that's required to bridge the gap. And I apologize for this. For some reason, I'm getting myself in a bit of a mess with the navigation. There's another motivation here, which is known as brittleness. Applications are usually very tightly coupled to a database schema. So the problem that arises, changes to the database schema break the object model. So writing DB agnostic code is very difficult and time consuming and error prone. And the reason for this is database schemas any change to the schemas are going to break the application, and you don't want that to happen. So the solution here is what's known as the entity data model. And the entity data model is based on a white paper by Dr. Peter Chen. You can look that up in Wikipedia. The entity data model provides an abstraction layer between your code and the database schema. And the basic concept behind an entity data model is that you have a domain model, which is also referred to as a conceptual model that you program against. And you are not dependent on, or the code that you write is not dependent on the underlying database schema. So the domain model and the entity data model itself is composed of what are known as entities, which are collections of classes, and the related associations, sets, and containers that are needed for working with the data and its relationship to the database. So we're going to set up an entity container that uses the Northwind database, and that container is going to describe for us a CRUD model, create, read, update, and delete, that models a pattern called a unit of work pattern. This container is going to contain what are known as entity sets, where the sets contain a collection of entities. Where, for example, if you have a table that in your database called category, you'll have a corresponding collection of category instances that represent the resultant rows in a query. We'll refer to this as an entity set of category objects, and they're pluralized according to the name of the table. For example, if you have a table called category, you'll have relationships that are associated with category sets called categories. Same for products and same for suppliers. So these represent, again, the result set of a query. So these relationships also provide you support for associations. For example, a category entity might have a one-to-many or a zero-to-many relationship with individual product entities. And again, these are associated with the classes that describe the conceptual model in our application. Now, how do we go from a conceptual model to a physical store? So here we have three different concepts. First is this conceptual model. The conceptual model is represented by a schema called the conceptual schema. The conceptual model in our application is going to model classes and their corresponding relationships. And this will be independent from the actual database table design. The storage schema, which we represent as a storage model, is the database design model, which includes the tables, views, store procedures, and the relationships and keys. And finally, we have the mapping layer. The mapping layer consists of information about how your conceptual model is mapped to the storage model. So now with this new notion of a mapping between the conceptual model and the storage model, the database schema can change without necessarily breaking the application. You simply change the storage and the mapping files. Visual Studio is going to build these for us and consolidate them into a single file known as an EVMX file. So there'll be a file with an extension of EVMX. Oh, goodness. Sorry about this. So let's talk about entity framework from the standpoint of how the mapping and the relationships between the types are going to allow us to, or give us the ability to query the underlying database. So remember I said earlier that entity framework enables .NET developers to work with relational data using domain-specific objects. And these domain-specific objects are defined in the conceptual model. So there are a couple of ways in which we can go about actually querying a database with entity framework. So to query a conceptual model, you can use either Linq to entities or something known as entity SQL. So entity SQL is a specific dialect of SQL Server, the SQL language. It's a storage-independent dialect of SQL. And this is designed to work directly with entities in the conceptual model that support the entity data model concepts. It's referred to as eSQL, entity SQL, and we can actually get more information about that by doing a quick search. So it's available to us through MSDN. Entity SQL. Let me just do this. MS SDN. Do a search. Here we go. So here's our entity SQL language and an entity SQL reference. Notice that this is an entire language. It's a dialect of entities of SQL that is specific to working with Entity Framework. Let me go ahead and copy this reference for us into the chat window. Now, most developers will use Linq to entities as a way in which we can query the underlying database. So Linq to entities provides language-independent query, which is referred to as Linq, support for querying entity types that are defined in a conceptual model. And as far as the information that we'll be retrieving from the model, the information in the model and the mapping files are going to translate these object queries against entity types that are represented in the conceptual model. And it's going to take those and translate them into data source specific queries. These query results that are returned from the database are going to be materialized into objects that Entity Framework will manage. And a key note on this slide is that the entity client data provider has a responsibility to convert L2E, which are referred to as Linq to entity, and eSQL, or entity SQL queries, into the language or the dialect that is understood by the corresponding data provider. So down at the bottom here, we have ADO.NET data providers. These ADO.NET data providers are specific to the corresponding third-party provider. For example, you have Microsoft SQL Server, you might have Oracle as a provider, you might have MySQL. So each of these specific providers have their own distinct raw or native dialect of SQL that is going to be emitted as part of the resulting query operation. And on the reverse, the data provider is going to take the information that is generated as a result of that particular query and feed it back through the chain, through the entity data provider, entity client provider, through a data reader, and make this available to your application as hydrated objects. When we're working with Entity Framework, we have, as I mentioned earlier, an entity data model context. This is going to be generated for us in Visual Studio as a DbContext class. Now, this DbContext class represents the entity container in the conceptual model. So recall earlier, I had a picture. Navigate back to that slide. Okay, so here we have an entity container. And in our example that we'll be putting together, it's called Northwind Entities. So that represents the DbContext that Visual Studio will create for us. And the DbContext is responsible for doing many things. In particular, it provides facilities that are going to be used to track any changes that are made, and also for managing distinct identity by keys. So just as we would have primary keys in our database, there will also be keys that are used to facilitate change tracking. Also concurrency and any relationships between the underlying types. There's also a very important SaveChanges method. The SaveChanges method is called upon the entity data set that with respect to any changes that have been made. So because Entity Framework is going to be tracking changes, any changes that are made will be automatically persisted to the database when the SaveChanges method is called. This includes inserts, updates, and deletes to the data source. We'll be looking at an example as to how this works coming up. There's also a very special set of classes that correspond to the not the Entity Framework API. There's one in particular called DBSet, and the DBSet is a special type of a container class that lets you associate your entities with collections. So when you perform operations on a database, for example, retrieving a set of products, you're going to be getting back a DBSet of product type. There's also built-in support for Linq. So when we use Linq to query the underlying database, these DBSet types are going to be represented as a special type known as queryable. And we're going to see that again coming up in an example. So notice that inside of my DbContext, I have defined here 3 different representations of DBSets. I have a DBSet of category, a DBSet of product, and a DBSet of customers. The constructor is automatically generated for us through Visual Studio, and this will be associated with a name that corresponds to an entry in the application configuration file that contains the mapping information for the storage layer, the conceptual layer, and the mapping infrastructure. Now, if for any of you who have worked with ADO in the past, you know that you have connection objects, you have command objects, you have reader objects. Well, with working with Entity Framework, you still have the same capability to open a connection, associate a connection with a command, and then perform operations, for example, querying a database using the reader. You can do the same thing with the entity client provider by going directly to the command object and executing a reader off of the corresponding command. So for example, you see here we're using a dialect of SQL called Entity SQL to retrieve all of the customers that are in the Northwind entities container. So we created a reader called execute reader, specify a command behavior as sequential, read through, and then execute the operation for each record. Now, it's important to mention that when you're working in this context, the result is not object-based, which means that you're going to be responsible for reading the individual fields directly. There is an example that comes with the set of demos that I provided on the OneDrive. There's also the link to entity support, which is where most developers will focus. This is represented by the object services layer. Again, let me go back to the big picture just to show you where this ties in. So link to entities. Link to entities is going through the object services, and the goal of the link to entities is to work directly with objects in your conceptual model, which means that when I query the database, I want to have instances of objects that represent a customer row, a product row, and so forth. So we'll set up our container, the Northwind Entities Context, and then issue an instruction that is based on Linq that retrieves a set of products. And then we have the ability now to simply iterate over that result set and display the results to the command line. Let's go ahead and take a look now at how this works from Visual Studio. So I'm going to open up Visual Studio 2013 and create a new project. And we'll start off with in Visual C# under Windows, and I'll create a console application. We'll call this EF Demo and click OK. So the first thing that we'll do is add the support for Entity Framework. Before I jump into that, let me show you one thing that you might take advantage of. With Visual Studio 2012 and Visual Studio 2013, we have this special option here called Manage NuGet Packages. If you click on Manage NuGet Packages and you select the Online tab, there's a search that you can also perform here to save yourself some time. You could type in entity framework. There we go. And you notice that entity framework came up. I guess I just misspelled. There we go. And there's entity framework that comes up for us. So you can click on install here directly if you need to use entity framework within a class library. Let's go ahead and close that out. Right mouse button, click on the project name, and I'm going to choose add new item. And we're going to add under the data menu item ADO.NET Entity Data Model. And I'm going to name this Northwind Model and get rid of the number 1 and click on Add. And this gives us both of the design tool entries that we can use for working with either an existing model or creating a model from scratch. We're going to start by generating a model from our database, and again, this will reverse engineer the database according to the tables that we select. I'm going to click Next. And we're going to select the Northwind database. If you see nothing in your screen, you choose New Connection, SQL Server, and Continue. And then from here, you enter your server name. I'm using SQL Express, so I type dot for the local machine / SQL Express. Enter a name for the database. Again, we're assuming that you've already set up the Northwind database, or if you haven't, you could do that after the presentation. And I'm going to select OK here, and then click Next. You have two choices, Entity Framework 6 or 5. We will choose 6 and click Next. At this point, we're going to be presented with information that was gleaned from the schema of the database, which shows us the set of tables, views, and store procedures and functions that are found in the Northwind database. So before I select anything here, I'm going to open SQL Express, SQL Server Express. And by the way, over here I have the instn wind.sql script file, which if you extract the zip file on OneDrive, just take the resultant file, copy it into SQL Server, and then click the Execute button. That will set up the Northwind database for you. So again, open this SQL file, click on Execute, and that will create the Northwind database. I'm going to go ahead and close that out. Okay, so in my Northwind database, notice that I have a set of tables in here. So I have categories, products, customers, and so forth. So we'll be looking at categories and products. And so in here we have, for our products, we have the set of columns that are defined by the schema. And same for categories. Again, columns defined by the schema. And then we have the relationships that are associated with the category ID, and the corresponding product has the foreign key for category ID. So we'll go to tables, expand DBO. I'll select categories and products. Again, if I wanted to bring in store procedures, I can do the same thing here. Click Finish, and the conceptual model will automatically be generated for us through Visual Studio. It's going to take the information that it finds from the schema, generate the XML definitions of the CSDL, along with the storage and the mapping. So when this finishes, we'll take a look at the generated code, and I'll also show you the mapping between the tables and the conceptual layer. So here you notice that we're getting a security warning. What's happening? Visual Studio is using or is attempting to use what's known as a T4 file to generate a DbContext. T4 stands for Text Templating Transformation Toolkit. This is not a problem, so I'm going to turn off the warning and click OK. And I'll show you what the resultant DbContext looks like when this finishes. It does take a while the first time through. So here you see that we have a designer window that contains two entities, category and product. So each of these entities corresponds to a class that in our conceptual model that is going to be mapped into a physical row described by the categories or products tables. The class information that corresponds to the category and product is available directly to us in Visual Studio. Notice if I click on Class View, you'll see here that we have both category and product available to us. If I double click on category, you see that it's a class as well as product. It is a class. There is no coupling with Entity Framework, so we're working with what are called POCOs, plain old CLR objects. Let's take another peek at some of the underlying infrastructure that's generated for us. I'm going to go back to my Solution Explorer window and going to go back to the Entity Data Model. Now notice that the Entity Data Model, as I mentioned before, has an EVMX extension, and I said that this is an XML file that contains the underlying mapping information that hooks up the conceptual and the store layer. So if I right mouse button click on the EVMX file and choose Open With, I can select XML. And this will give us an indication as to what's actually being generated for us behind the scenes. And you see, in fact, it is an XML file. This describes the storage layer along with all of the information that is used to generate the types that correspond to our categories and products. Scrolling down further is I'm sorry, at the top here. I was looking at the wrong thing. This is the store, right? The storage layer. At the bottom here we have the conceptual. So this is the actual description of the class that we use in our conceptual model. Very similar, almost a one-to-one. And scrolling down even further, we see the mapping. So these entries in here bridge the gap between the objects that we use and the underlying database schema information. So again, there's a mapping that corresponds to all of these entries. I'm going to close that out. And back to our Northwind model in the designer window. We can also look at the mapping information for the individual entities. Right mouse button click on category or right mouse button click on product, either one, and choose table mapping. And this shows us the details that correspond to, on the right hand side, the conceptual, and on the left hand side, the store, the table itself. So each one of these has a corresponding name and type that maps to a name and type. So on the right and left, that hook together the pieces. So that gives me the ability, if I wanted to change, add, or remove entries, I can. So if I wanted to call product name something else, like just name, I could do so. So I just change this to name, for example. Go back to my mapping. And you see that name here maps now to product name. Let's put it back the way it was. Product name. You can also add additional entries in here if you need to, or remove. So for example, picture. If I don't want the picture to be returned as part of the result set, I just remove the entry. So I select picture and delete. Now, one of the caveats here is you want to be sure that you don't delete anything that is required. So the next thing that we're going to do is take a look at what the corresponding set of entries are that are given to us in our entity that make it easier, facilitate relationship traversal. For example, given that I have a category, if I want to find the set of related products, it's very easy to note that by looking at category, there is a special entry in here called products. So if I have an instance of a category object and I want to see all of the related products, rather than having to find the relationship key, navigate through that key, and then programmatically access all of the related products that match that particular category ID, I can easily do so by going through this what's called a navigation property. The navigation property is defined for us as part of the class that it's generated. So if I go back to class view and double click on category, you'll see that there's a special entry in here called products. And this represents a collection of products that are going to be made available for traversal by using a simple Linq expression with a nested loop. So this is something we'll take a look at shortly. I'm going to go back and show you one more nice little feature that we can take advantage of in using the designer. If I wanted to add an additional set of table entries from the storage layer into my conceptual model, I can do so by going to the designer window, and with my right mouse button, I can select I can select Update Model from Database. So doing so lets me come back to this Add menu, and in here I can add additional entries. For example, now if I wanted to add customers, I can do so. If I wanted to add employees, I could do so. And again, if there are relationships between the two, they will also be built in for me. I'm not going to do that, but feel free to play around on your own. I'm going to choose Cancel. And one more thing before we start writing some code. If I right mouse button click on the designer again, there's an option here for going to what's called the model browser. And the model browser gives us a visual representation of the XML file that I showed you earlier. So you'll see here we have at the bottom the Northwind Model store, and in here we have the tables that correspond to the schema. So here's our categories, and here's our products. We also have the entity container itself that describes our entity. So notice the name here, Northwind Entities. This is what we'll use as our context. Northwind Entities represents our context. If I expand this, it shows us the entity sets, along with any association sets that are needed for traversal. So I'm going to expand entity sets, and there's our categories, and there's our products, and the association sets as well. So this is the foreign key association between the products and the categories. You also have the associated entity types that are described at the top here. So notice that the entity types, category, and product are going to be similar to the categories and products in the table, but we don't program against the actual physical store. We program against the entity types that are described by our model. So anyway, let's write some code now. I'm going to go to my my program, and we're going to start by adding a using statement. And we're adding the using statement because we want to make sure that we dispose of the container when we're finished, the DbContext. So remember that I said that the name is Northwind Entities, and I'm going to give this an ID of CTX. And we'll create an instance of that container, and from here we have the context at our disposal. And the context is going to give us access to the DBSets, categories, and products, and you'll see categories and products immediately visible. Also note that the return type is a DBSet of product and a DBSet of category for this one. Okay. And as I also mentioned, I can use Linq directly to make a very simple request to retrieve my categories and products in one fell swoop. So I'm going to say categories here is going to be associated with an expression from the context that hooks into or dives into the categories DB set, but I want to order my set by category name. And now I'll choose select C when we're done. So again, you have complete access to your knowledge of Linq directly through Entity Framework. And now let's write some output here. I want to see what this expression, this Linq expression, corresponds to from the standpoint of the instructions that will be sent out through the provider. So we're going to use an overload to the toString method and look at the translation of that Linq expression. So I do want to mention that this Linq expression is not going to be evaluated, and it uses deferred execution, so it won't be evaluated until we actually invoke some method that requires the result set to come back. But notice that here we have an operation that says select the category ID, name, description, etc. from the categories database, and there's our order by. So something is happening there. Okay. Let's now take this a step further and actually retrieve some data. So we'll use a simple for each loop, and we'll choose categories here. Okay. So what is the type that's actually coming back here? So I use var, which uses a simple way to name the result type using compiler inference. But if I wanted to know what the actual type that's returned from this Linq expression, one way is to simply put my mouse over categories. But you can always note that Linq will return something that is IEnumerable. It turns out that when you're using Linq, it's going to return something that is a lower level called an iQueryable. And an iQueryable is a special type of query that is sent directly out to a database. So this, because I use order by here, it's an IOrdered queryable. So I'm going to change this to be more explicit, more specific. So it's an IOrdered queryable. Okay. Or I could just say iQueryable. Either one works. And the type is category. There you go. So I know that my categories contains a set of category entities. So I'm going to change this to category. Just again, I don't need to do any of this special name changing, but just so you can see what's going on. And we'll call this category. And let's go ahead and write out some information. So what we'd like to see here is just the category name. So we'll print out the category name. There you go. And that should be a good starting point, assuming that there are no mistakes in there. And there we go. So those are the category names. Let's take this a step further. If we go back to the entity designer, recall that we have, with each entity, we have a corresponding set of of products. And we have the ability to use the navigation property to retrieve dynamically, it turns out, to retrieve dynamically the set of related products. And this uses something known as lazy loading. In other words, load only when necessary the set of related entities. So when I asked it to get my categories, it said, I really don't need those. However, now when we use them in context, we'll be able to retrieve them. So I'm going to add another loop, another nested for each in here, and iterate over the products that pertain to each row in the result set. So we'll say here category dot, and in here is the products entry. And notice that products is iterable. It's going to provide us something that results in a collection of values. So I'm going to get the product information here, and this will be our product. So we'll write that out, put it in a tab so that we can see the output of each category. And we'll print out the name and the price of the product as currency. And so that will be product.name and product.unit price. Okay. Oh, looks like look at this. Okay. When I was changing the, okay, it looks like I misspelled. Look at, I misspelled that, but it did pick it up. All right, so I made a small mistake, but that mistake shows you that the conceptual model is being used. It's a misspelled name. I'm going to leave it as is. Let's go ahead and look at the outcome. So I go to debug and start without debugging. And now here you have the set of categories and the corresponding set of products within each category. Now I mentioned this, the notion of what we call lazy loading. You can actually take control of that if you don't want to use features that are given to you. You do have the ability to control that. You can find that information online. We have a 3-day course in Entity Framework where we go over those details. So let's move on with the slides. Okay, so it turns out that we can also make changes to the underlying database. And so again, this comes into play when maybe you want to change the price of a product or increase the number of orders, and it might even require you to traverse your tables. So again, we can take advantage of this the conceptual model and the traversal features that are given to us through the navigation properties. So here's an example as to how we can work with Entity Framework through taking a set of products and look for any entries in here that might need to be removed, and then go ahead and remove them from the conceptual layer. And I'm sorry, remove those from the context through the SaveChanges. Now that doesn't actually remove the objects from the database itself until we call SaveChanges, but the context is keeping track of any entries that have changed state. So when we call remove, as you see here, the state changes. And when the state changes to remove, we call SaveChanges. That persists those changes for us. So there are 3 different ways in which we can make changes. Number 1 is to explicitly call remove. Another is to call add. And another is to call or not make any name change, just directly change a value. So for example, let's go back to our code example here. If I wanted to, let me open up my program. If I wanted to retrieve my category information, and then for each product I wanted to increase the price of the product, all I would need to do would be this, product dot unit price plus plus. Okay, that's going to increase the price of each product. It will change. It'll be changed within the context, but the actual values won't be persisted to the database until we call save changes. Which would mean if I wanted to persist these changes, I would do something like this: ctx.SaveChanges, and that would save all the changes to every product's price that I've increased. So the example that I just showed you is simple enough, but there are some things that can be somewhat confusing when you're working with these entity states. So I thought it would be worthwhile to go over what the entity states are that are available. So Entity Framework, as I mentioned, takes care of tracking the state of your entities as they are changing with regard to operations that take effect during the life cycle of the method calls. So an entity can be in one of 5 states that's defined by something given to us called an entity state enumeration. And that list is added, unchanged, modified, deleted, and detached. And it's a good idea for you to be familiar with these when you're first starting to work with Entity Framework. So behind the scenes, Entity Framework is going to keep track of the original values and the current values. So original values means those values that correspond to the initial request from the query. So bring data in from the database and hold the original values in context. So when you first make a request to the database to retrieve a set of products, the original values and the current values will be the same. Once you make a change, for example, increasing the unit price of a product, the original value stays as is, but the current value is going to change. So the state is going to change in this case here from being unchanged to being modified. And when we call save changes, because the state is modified, and I mentioned that save changes affects anything modified, deleted, or added. So in any of those 3 cases, save changes will persist back to the database. So let's look at a nice example of this. If we go back to the OneDrive samples that hopefully you've downloaded, I have an example that we're going to take a look at. Let me just go ahead and open up my samples folder. There we go. So in here is an example called entity state. And so on the OneDrive folder under samples, it would correspond to this zip file right here, entity states. And we'll take a look at this example. I wish it were faster, but maybe my machine's getting old. It's several years old now. So, okay. So the first thing we're going to do is take a look at the entity data model that I've set up for us. It's a very simple Northwind model again, so that you'll be able to use this to walk through and make changes as necessary. So I'm going to just double click here on the Northwind model, and that will open the designer window for us. Painfully slow, my apologies. When this finishes loading, we'll take a look through the code as well. I'm not sure why it's frozen, but it looks like it might be. So for those of you who haven't, oh, there we go. All right. So notice that what I've brought in to the designer window is a product entity, and this is going to map again into the product table.
I didn't make any changes here regarding the set of fields, but feel free if you wanted to practice, you can change the names or whatever you need to. So back in the program, let's see what I set up for us. First thing that we're going to do is retrieve a product row from the database with an ID of 1, and it turns out that this happens to correspond to a product called Chai. So I'm using a special method called find that lets you pass in the key value. And remember, I mentioned earlier that we have keys that Entity Framework uses to track entries within the context. So these keys map into the primary keys that are used by the database in SQL. And I wrote a method here called display that will display information about the product ID, name, price, and also its current state. So you'll see it'll be in one of those 5 states as we go through. So again, here we have retrieving the data. The next thing we're going to do is increase the price, display the state. The next thing we'll do is create a new product. So we're going to create a product that represents Kahlua coffee. Chai is tea, Kahlua coffee. Think about what happens here. We create a new product, and I call display. What state will that be in? So before I run this, I want you to think through what you expect to see and what we actually do see. So we create a product, display it. The next thing we do is add a new product to the entity. I'm sorry, to the context. So we're going to add this new entity here, Kahlua, to the context. Look at the state. So will it be the same or different? We then call SaveChanges and look at the results. So I'm going to be looking at display the Chai after SaveChanges and display Kahlua as to what the changes of state will reflect. Will they be the same or different? They should be the same if you think about it. The question becomes, what will be the state after you call SaveChanges? So, and lastly, this one, it turns out, is probably the more challenging. We're now going to delete. Remember I mentioned earlier that we call remove to delete an entry. So we're going to delete Kahlua, which is that new product that we created. So we call remove and display. So you could probably guess as to what the state will be at that point. And you 90% of the time, most people get that one right in class. But here's a challenge. So at this point we've removed it from the context, but we haven't actually deleted that row from the database. So now I call SaveChanges. SaveChanges will physically remove that row from the database. And now we're going to look at the results. So when we call display here, we'll see what the state is. So give it some thought. Again, back to the slide here. These are the options you have: added, unchanged, modified, deleted, and detached. Right? So let's go ahead and run this through. There we go. Looks like it's thinking. It says build started. There we go. Okay, so the first thing we're going to do is get the product and look at the entity state. Hit enter. There we go. So brought in product 1 unchanged. So that means that the current value and the original value are the same. We have yet to call update price. So when I hit the enter key, it's going to update the price. But again, we haven't saved it yet. Okay. So it's gone from unchanged to modified. So at this point, the original value is still available to us. The original value is still 20, but the current value is 21. going to create a new product. All right. Notice that the ID of the product that I created an instance of an object. I didn't specify what the ID should be. It turns out that in the database schema, the key is an identity value or an identity column. So I didn't want to have to pass it in. In fact, if I did, it would be ignored. Right? So it sets it inside of the instance, it's value 0. But notice that it's detached. Right? This is interesting. So I created a new object, and Entity Framework says, well, it's not part of my context, so it's represented as detached, which means I have to now add it to the context. It's a big mistake people make, because they'll create a new instance of an entity, so effectively they're just creating an instance of an object, and they make changes to it, and they save the changes, and nothing's happened. And the reason is that they've never added that entry, that entity into the context. Right? So that's a key. So I said, for an important little walkthrough. So we're going to add the new product to the context. Notice now that the state is changed to added. Now we call save changes, and I asked you to think about what the new state will be after you call save changes. Okay, so some people might say, well, added. Okay, probably not though. Well, when you call save changes, you're effectively going to think of it as going back to the database and getting a new fresh start. Right? So we call save changes and hit the enter key, and notice that now the new value and the original value, the current and the original, are the same. So the state is unchanged. It is still attached. In other words, it's still part of the context. At this point, we're going to call delete. All right. So you probably guessed that one, deleted. We haven't called save changes, which means if I were to go back to the database, and let's go ahead and do that. I'm going to go to my products database. I'm sorry, to the products table in the database, and we'll go ahead and select the set of rows. It should be somewhere in here, probably down at the bottom, I would guess, right? So let's go ahead and find that. All right, so there's Kahlua. There's Kahlua coffee, right? So it's in the database. Notice it has a unit price. It has a product ID. All that's been generated for us. Okay, so let's go ahead and save changes. Okay. Interesting. It's now detached. Now look at this. Detached, which means it's gone from the database, but the object or the entity that represents that product is still available to me. So I can reattach it if I wanted to. if I wanted to, and then add it back. Okay. So let's just assure ourselves that it's actually been deleted from the database. I'm going to go ahead and execute the select statement again, and you notice that it's gone. All right. So hopefully you found that to be somewhat helpful. Let's we don't have much more to go here. Okay, so that was our demo. So a couple of other things that are available to you. I mentioned that when you work with Entity Framework, you'll be using this new dialect of SQL called Entity SQL. But in some cases, maybe you don't want to have to go through the entity client provider directly. So that means that you can go directly to through Entity Framework to the underlying data provider. So we have the ability to pass in direct SQL commands using standard query language SQL. But again, this is not going to go through the entity client provider. Instead, it's going to go directly to through Entity Framework to the underlying provider. So it might be worthwhile just seeing a quick example of this. But notice that we have the ability to specify queries and also to execute commands, which means performing cut operations. And this is similar to working with SQL pass-through you may be familiar with. Okay. These are all executed within a transaction by default in Entity Framework 6. And notice it says it wraps the command in a transaction automatically if one does not exist. And if you're familiar with the transaction scoping, you can actually enclose this within transaction scope if you need to. So there is an example I have of this. Just to, I'll just open it up and show you if you're interested. This is under store commands. By the way, this particular feature that is available to us is not something that you would want to use frequently. So here we have a simple example that, again, we set up our Northwind entities. And I'm going to specify here that I want to create a query off of the database. And notice that I'm using direct SQL instruction here. So again, I'm bypassing the need to use entity SQL. Select star from products where. This is something that you can't use when you talk directly through entity SQL. So this is a DB SQL query. A couple of things that you'll note. I have a using statement up here. You're going to be using system.data.entity.infrastructure along with system.data.entity. And let's just go ahead and run this. And I'll enter a category ID of 1. And there you go. So again, this is very similar to like a SQL pass-through operation, but you still have access to the type information, right? So the type information is there for us. So it's going through another route. You're not at the top going through the object services layer. And lastly here, asynchronous support. So this is a wonderful new feature that was added in Entity Framework 6 to provide asynchronous operations directly through the entity set. So with the DbContext. So there's a special set of async operations, asynchronous operations that we can use that are built into the Entity Framework and through Linq that we can take advantage of. So there's an async method that provides a way in which we can prevent the code from blocking the user interface. And what we'll normally do in a Windows form-based application or a WPF application, you're going to have a button. The user clicks on a button and we want to maybe retrieve a set of rows from a database, and it could be a very long running operation. It could take several seconds, and the UI would be blocked. The user would not be able to interact with or even cancel the operation. So what we can take advantage of are these extensions that provide us asynchronous operations. There are numerous extensions that are given to us in DBSet. They're asynchronous. And it's kind of the rule of thumb is anything that takes longer than 50 milliseconds should be considered to be something that is asynchronous. So let's see how this works. So I'm going to open up the last example here, which is async, EF async. And I've created a data form that it's a Windows form-based application. So I have a data form that when I run the application is going to bring in some data into a window. So let's take a look at the data form. And I have two buttons on here, one for synchronous and one for asynchronous. Load products sync and load products async. So just to show you the benefits of asynchronous operations. If I click on load products sync, okay, and I try to interact with the form, excuse me, okay, it looks like I'm kind of locked out. There we go. Let me run that again. I kind of muddled that. Okay, run it one more time. Okay, so when I click on, notice right now I'm able to move the window. If I click on load products sync and I try to interact with this, I can't move the window. Okay, and I actually set up a 3-second delay in here. Okay, if I made it longer, again, it would be even more annoying. Okay, so let's look at the code. So here we go into our data form and data form code. There we go. So I have a load products button here. I'm just going through the normal operations that are available. Here I'm writing, there's a method called load here that brings the data into context. I added an arbitrary 3-second sleep in here, and then I bring the data into context. Let's go ahead and run this now with the asynchronous support, and then we'll look at how I wrote the code there as well. So if I click on, again, there's a 3-second delay built into this as well. So I click on load products, but you'll notice I am able to, when I click on load products, there we go. There's going to be a bit of a delay that you'll notice either way, but when I click on the load products async, it doesn't become as intrusive as you would otherwise expect. Again, let me run that again just to demonstrate. In fact, let me run it without the debugger. Sometimes that makes it better. Okay, so again, without hitting the button, now I'll click on the button. There we go. Much better. Sometimes the debugger slows things down. So if I increase that to 10 seconds, again, you would not notice the difference in the user interface. So what I did, I called load async because I don't have very many records in the database for products. I also added a delay here of 3 seconds. This is using asynchronous operations with tasking. So notice that the only change I made, I marked this method as asynchronous. So there's a special async keyword that's available to us in C# version 5 with .NET 4.5. Yeah. And now when I call load async, the load async method, notice in the little quick help that appears down at the bottom, it says usage await load async. You can see that down at the bottom of that little help window. Yeah. So await says I have a potentially long-running operation that's going to be kicked off as a separate thread of execution, but I want to return control back to the caller. So in other words, this doesn't say block the UI thread. It says execute that operation in a separate thread, but return control back to the UI. And when the data or when the results are available, then bring those into the corresponding UI control. And you don't have to worry about thread dispatching issues that you would have had to address if you're familiar with those issues from prior days of .NET. Okay, so anyway, this comes in handy. That support is directly available to us now with Entity Framework. And there are many, many different cases where this comes into play, by the way. So if I, just to show you, if I go to products here, you notice that we're just going through the list here. We have any async, you have, and again, we have the DBSet, average async, contains async, count async. So there are a slew of these that are available to us. Okay, and lastly here, just a reminder for those of you who might have come in just a little bit late, to download all of the materials, the PowerPoint slides, and the demos off of OneDrive. This is case sensitive, so I'm going to just put this back into the window, into the chat window. Okay, and also put my email address should you have any questions. Okay, and to use the Northwind database, once you go to OneDrive, you want to unzip this. There's a inst nwnd.sql script file. Just bring that into the SQL Server or SQL Server Express window, and then execute. That should set up the database for you. You can also get this database directly from Microsoft. Just do a Google search or a Bing search for the Northwind database, and you'll be all set. So, and that's it. So anyway, in summary, we had discussed the entity data model and how we can take advantage of the simplicity now of just working directly with our object model without having to worry about the underlying database infrastructure and having to worry about navigating between the relationships. And also the different approaches that you have, Entity SQL directly with data readers, Linq to entities, which is the most common approach that you'll use. And again, thank you for your time. If you have any questions, just shoot me an email. I'll be more than happy to help you out. And take care. Thank you.